So we're going to proceed for week 2, for our topic for week 2. We have what you call Charles' Law. For Charles' Law, this is our learning task 1. You have to read the short discussion about Charles' Law and familiarize yourself about the commonly used units for volume and temperature. The volume-temperature relationship gases, K equals B over T, was determined by a man named after Jack Charles. In this experiment, Charles trapped a sample of gas in a cylinder with a movable piston in water bath at different temperatures. He found that the different gases decreased their volume by factors 1 over 273% per degree Celsius of cooling. With this rate of reduction, if a gas will be cooled up to 273 degrees Celsius, it will have 0 volume. He stated that at constant pressure, the volume of a fixed amount of gas is directly proportional to the Kelvin temperature. The formula, the general formula is V sub 1, V sub 2 equals T sub 1, T sub 2. Where V sub 1 is the initial volume, V sub 2 is final volume, T sub 1 is initial temperature, T sub 2 is final temperature. The formulas in getting V sub 1 and T sub 1. The formulas in getting V sub 2 and T sub 2. The commonly used units for volume and temperature. For volume, we have the SI unit, the cubic meter, the cubic decimeter, the cubic centimeter. For the metric unit, we have the liter and the milliliter. For the English unit, we have the quart and the gallon. For temperature, we have degree Celsius. For metric unit, we have Kelvin. We have degree Fahrenheit. Note, the unit for temperature must be converted into Kelvin unit first by adding 273 to any degree Celsius. Charles' law gives the relationship between volume and the temperature if the pressure is constant and the amount of gas are held constant. If the Kelvin temperature of a gas is increased, the volume of the gas increases. P and N are constant. If the Kelvin temperature of a gas is decreased, the volume of the gas decreases. This means that the volume of a gas is directly proportional to its Kelvin temperature. Think of it this way. If you increase the volume of gas and must keep the pressure constant, the only way to achieve this is for the temperature of the gas to increase as well. So here is the figure how Charles performed his experiment. The concept of Charles' law is evident in an inflated balloon that shrinks when inflated inside the refrigerator. It is also applied during cold weather. The bicycle tires become flat because the air inside the particle tires shrink. The shrinking of an inflated balloon in a bicycle tire in a very low temperature shows the decrease of volume, which explains that the relationship of volume and temperature is directly related at constant pressure. So we go with Charles' law, and it is what you call problem solving. For a sample problem, an inflated balloon with a volume of 0.75 liter at 30 degrees Celsius was placed inside the freezer, where the temperature is negative 10 degrees Celsius. Find out what will happen to the volume of the balloon if the pressure remains constant. Support your answer with computation. We substitute the value. V sub 1 is 0.75 liter. V sub 1 is 30 degrees Celsius. We need to convert this to Kelvin by adding 273. It will now become 303 Kelvin. For T sub 2, it is negative 10 degrees Celsius plus 273. The answer is 263 Kelvin. Please don't forget to convert the temperature to Kelvin when we are solving Charles' law problems. So we are going to find out B sub 2. The formula for that is B sub 1 T sub 2 over T sub 1. Following with substitution, B sub 1 is 0.75 liter, T sub 2 is 263 Kelvin, T sub 1 is 303 Kelvin. 0.75 times 263 is equals to 197.25 liter Kelvin divided by 303 Kelvin. Our final answer is 0.65 liter. For learning task 2, we answer the following Charles law problem to facilitate mastery of concepts on the volume-temperature relationship. Problem number 1. A cylinder with a movable piston contains 250 centimeter cube air at 10 degrees Celsius. If the pressure is kept constant, at what temperature would you expect the volume to be 150 cubic centimeter or cm cube? B sub 1 is 257 m cube. Temperature is 10 degrees Celsius plus 273. It will become 283 Kelvin. B sub 2 is 150 centimeter cube. So we have T sub 2. We are going to find that. The formula that we are going to use is T sub 2 is equivalent to B2, B sub 2, T sub 1, and B sub 1. Substitute the value. B sub 2 is 150, T sub 1 is 283, B sub 1 is 250. For the solution, we multiply 150 by 283. Our answer is 42,450 centimeter cube Kelvin over divided by 250 cm cube. Cancel the unit cubic centimeter. Our final answer is 169.80 Kelvin. The volume decreases, so the temperature is also decreased. For Charles' law, problem number 2, a tank which is not frigid contains 2.3 liter of helium gas at 25 degrees Celsius. What will be the volume of the tank after heating it and its content to 40 degrees Celsius temperature at constant pressure? Our given is 2.3 liter. T sub 1 is 25 degrees Celsius plus 273. It is equivalent to 298 Kelvin. T sub 2 is equivalent to 40 degrees Celsius plus 273 equals 313 Kelvin. And we're going to find B sub 2. The formula that we are going to use is B sub 2 equals B sub 1, T sub 2 over T sub 1. Substitute the value. B sub 1 is 2.3 liter, T sub 2 is 313 Kelvin, T sub 1 is 298 Kelvin. Multiplying 2.3 by 313, the answer is 719.9 liter Kelvin. Divided by 298 Kelvin, cancel the unit Kelvin. Our final answer is 242 liter, which means that the temperature is increased, so the volume is also increased. Problem number 3. At 20 degrees Celsius, the volume of chlorine gas is 15 decimeter cube. Compute for the resulting volume if the temperature is adjusted to 318 Kelvin, provided that the pressure remains the same. Identify the given. B sub 1, 15 decimeter cube times 1 liter. It is equivalent to 15 liters. T sub 1 is 20 degrees Celsius, add 273 equals to 93 Kelvin. T sub 2 is 318 Kelvin. Let us find B sub 2. Substitute the value. So the formula that we are going to use is B sub 2 equals B sub 1, T sub 2 over T sub 1. So for substitution, B sub 1 is 15 liter, T sub 2 is 318 Kelvin, divided by 293 Kelvin T sub 1. So 15 times 318 is equivalent to 4,770 liter Kelvin. Divided by 293 Kelvin, cancel the Kelvin unit. Our final answer is 16.28 liter. The volume decreases, so the temperature is decreased. So our next topic is an activity demonstrating Charles' law. At the end of the activity, you should be able to point out examples that shows the relationship of volume and temperature at constant pressure of a gas through observations. Materials, paper, pencil, and pen, and illustrations of different objects. Observe the illustrations in figure 2 to 3. Read the procedure, then write your observations briefly. To complete the discussion, fill in the blanks with the following words: gases, temperature, and volume. For procedure observation discussion, simply blow up 2 balloons to equal size. Place one on ice and one in just boiled water. What happened to the volume of the balloons? The increase in temperature will force the air to increase its blank, thus expanding the balloon. It will look like the balloon is growing or inflating inside a container with hot water. For procedure 3, press 3 to 4 ping pong balls until it becomes dented. What would you do to a ping pong ball which is out of shape or crushed? Put them in a bowl with hot water. What is your observation? When you let your ball float on hot water, the blank of the air inside the volume also increases, which in turn leads to an increase in the volume of the gas. Therefore, the shape of the ball is restored. Based on your observations in figure 2.3, you can say that various blank expanded by the same amount when heated through the same temperature interval. That's all for week 2, Charles' Law. Afterwards, you have to answer the week 1 to 2 weekly assessment, which is 20 points. That's all.